So Android leverages Linux user management to isolate apps. Yeah, so this approach is different from user management in traditional Linux environments where multiple apps are often run by the same user. But here, Android creates a unique UID for each Android app and then runs the app in a separate process. So consequently, each app can access its own resources only. And this protection is enforced by the Linux kernel. Generally, apps are assigned UIDs in the range of 10,000 and 99,999. Android apps receive a username based on their UID. For example, the app with UID 10,188 receives this username, use0_a188. And if the permissions an app requests are granted, the corresponding group ID is then added to the app's process. So let's have a look at how sandboxing works. So imagine you're downloading apps from Google Play. These apps are executed in the Android application Sandbox, which separates the app data and code execution from the other apps on the device, right? So this separation adds a layer of security. Now, applications run under well-defined and constant UIDs. Android does not have the traditional /etc/password file, and its system UIDs are statically defined in the Android file system config header file. Application UIDs are also written to the data system packages list file. Additionally, each application is given a dedicated data directory, which only has permission to read and write to. Therefore, applications are isolated or sandboxed, both at the process level, by having each run in a dedicated process, and at the file level, by having a private data directory. So this creates a kernel-level application sandbox, which applies to all applications, regardless of whether they're executed in a native or virtual machine process.